In this video, we're going to take a look at absolute values. The absolute value means the magnitude or the size of a number ignoring its sign. For a real number a, the absolute value is written as a, and then we put 2 bars around the number expression. Now make sure that you draw these bars a little bit taller so they don't look like ones. And then this will mean that it is a positive number. Now we can think of the absolute value of a number as its distance from 0 on the number line. So let's draw a number line, and we'll use this for our examples. We'll go from 0 and then 1, 2, 3, and 4 in the positive direction, and then we'll do the same thing in the negative direction. All right, let's come up with our first example. So let's say that I want to find the absolute value of 3, positive 3. On the number line, 3 is right here. And the distance from 3 to 0 on the number line is a distance of 3. So we say that the absolute value of 3 is equal to 3. So the absolute value of a positive number is that positive number. All right, next, let's see, we take the absolute value of 0. So since 0 is already 0 distance from 0, we say that the absolute value of 0 is 0. Okay. Lastly, let's take a look at a negative number. So let's take the absolute value of negative 3. So that distance from negative 3 to 0 is also a distance of 3. Now what we can think of is the absolute value of a negative number is the negative of that number, and that results in the positive value of that number. So we can write the absolute value of negative 3 is equal to the negative of negative 3, which is why we get positive 3. All right, let's summarize this. We can say that the absolute value of a real number a is defined as, and we draw the symbol absolute value of a, and that equals, and we're going to branch this off with the curly brackets into a and negative a. So the absolute value of a will equal a if a is a positive number, greater or equal to 0. And then the absolute value of a, it will equal negative a if a is less than 0. Now this might seem weird that it will be a negative number, but remember that a is already negative, so therefore negative of a negative number will make this second bottom part to be positive. All right, let's take a look at some examples on how we would write our answers. Okay, the first one, we have the absolute value of 9. So the distance from 9 to 0 on the number line is 9. The second one, we have negative 12, and the absolute value of negative 12. So the distance from negative 12 to 0 on the number line is a distance of 12 units, so 12. Now if you want to write everything out, this would mean that this is going to be negative and then negative 12. So that's why it becomes positive 12. All right, so doing the same thing as negative 12, the absolute value of negative 7 would then be positive 7. All right, let's next take a look at evaluating absolute value expressions. Now, we can think of absolute value symbols, and we can treat them in the same way as brackets or parentheses. Now, we evaluate the numerical expression inside each absolute value symbol first by applying the order of operations and then taking the absolute value of the result. So let's take a look at these examples here. So we have the absolute value of 2 and then minus the absolute value of negative 8. Now how do we know that the absolute value is not around the negative sign? Well, absolute values don't go around just a symbol. It has to go around a number or an expression. So in this first example, the absolute value is around 2 and then around negative 8. So the absolute value of 2 is 2. And once we take the absolute value of a number, we don't need the bars anymore. And then we have the minus sign in the middle. And the absolute value of negative 8 would then be positive 8. So we again remove the absolute value symbol. So then 2 minus 8 is then negative 6. All right, let's take a look at the next one. So they're getting longer and longer. So this time the absolute value is around the 1 minus 4. So we're going to evaluate that first because it's kind of like brackets and we want to evaluate that part. So we have 7 minus 3, which I'm going to rewrite down. And there's nothing connected to 3 and this absolute value symbol. So that actually means times in the middle. And then 1 minus 4 is negative 3. Now I'm not taking the absolute value yet. So I'm going to leave the absolute value symbol there and put the negative 3 inside. Now let's evaluate the absolute value of negative 3, which will then be positive 3. Okay, so now we can remove the absolute value symbol and just write 3. And doing order of operations, we're going to go 3 times 3 first. So that's going to be negative 9 or minus 9. And then 7 minus 9 is negative 2. All right, our last example, notice that all of the numbers are inside the absolute value. So we're actually going to take the absolute value at the very, very end. So I'm going to place them first, and we're going to evaluate by doing our order of operations. Often we will say BEDMAS, B for brackets. So we have negative 3 minus 1 is our first operation. So we're going to have negative 4, and then we're going to square, and then plus 6. All right, we still are not taking the absolute value yet. So we're going to now use our second order of operation, which is exponents. So we have negative 4 and squared, and that's going to be positive 16. Okay, next we have our multiplication. So negative 2, we have our times 16. So that would be negative 32, and then plus 6. And then we have negative 32 plus 6, which is negative 26. Now notice I don't take the absolute value, or I'm not applying the absolute value until the very, very end, because that is our last operation, because it's on the outside. So then finally, the absolute value of negative 26 is going to be positive 26. And then that's it.